Hello, this is question 12 on your A-level Edexcel sample paper, but it's a question that perfectly you should be able to do in year 12, yeah, because it has nothing that you learn in year 13. So we have to solve between minus 180 degrees and 180 degrees this trigonometric equation, and we have to give answers to two decimal places. So I have sine square, sine and cos square. So the first thing you have to do when you have sine and cos is to try to leave only sine or only cos, wherever it makes more sense. So in this case I have sine square and sine, and it's easier to just use the identity to eliminate this cos and write 1 minus cos square. So as I know, 1 minus sine square, as I know that cos square x, cos square is 1 minus sine square x. I'm going to substitute that here, and I'm going to write that 3, so this is a 3 sine square x plus sine x plus 8 is going to be 9, 1 minus sine square x. Expanding brackets, I have 3 sine square x plus sine x plus 8 is 9 minus 9 sine square x, and now I have everything in sine x. I put together the sine square and sine square, so I have 12 sine square x plus sine x, and I can put together the 8 and the 9, and I have minus 1 equals 0. And every time you have something squared, something squared, you're going to work with it like a quadratic equation. So this is, if we make this change, if you want to see the way, if we call y to sine x, really what we have is 2y squared plus y minus 1 equals 0. Yeah, if you want to work this way, changing your variable is okay. If you can work straight away this way, is perfect as well. So if you factorize this quadratic, you have 4x, I'm talking of y's, let's go to write y then. 4y minus 1 and 3y, plus 1 equals 0. So I have two solutions, and I'm going to make them equal to 0, both of them. Instead of y, I'm going to write sine x, yeah? So I'm going to go back to my left-hand side, and I have two solutions here. One is 4 sine x minus 1 equals 0. So this is the first one, which means sine x is 1/4. And the other one is going to be this other bracket. But I'm going to work first this solution and find all the answers, and then go to the other. Now, once I have sine x equals 1/4, I just do sine minus 1 with the calculator. Be sure that you are in degrees, because we are working in degrees, and find the first value of x. If I do sine minus 1, and they ask me to round to two decimal places, right? So I do that with the calculator, and I find that x is 14.48 degrees. That's the first solution. I need to find the others. To find the others, I can use the circle, if you like using the circle. So 14.48 is an angle here. Well, smaller, but yeah, 14.48. And I'm talking about the sine, so is this here. I need another angle or angles that has the same sign, and they are in the interval minus 180, 190. So the symmetrical in the y-axis will have the same sign. And if this angle here was 14.48, this one here is going to be 180 minus 14.48. So that second solution is 165.52 degrees. Yeah, and I don't have any other, because the next one would go a whole term plus 14.48, and it's completely out of our interval. Yeah. So these are two solutions that this first bracket is giving me. Yeah, so this first bracket. Now I'm going to do the second one, 3y plus 1, and I'm going to delete this to have 3y plus 1, which means 3 sine x plus 1 is 0, means sine x is minus 1/3. I use the calculator to find the first one, and x is sine minus 1 of that, which is minus 19.47. Is negative, and that's okay because it's in my interval. So many times the interval is between 0 and 360. This case is okay to write the negative one. And I'm going to find another answer. So I'm going to use again the circle. This angle is minus 19. So it's this way. When I measure negative angles, I go clockwise. So 19 minus 19.47. I need the same sign. So again, the symmetrical in the y-axis. The symmetrical in the y-axis would have the same sign, but we need the negative angle. Yeah. So the negative angle will be minus 180 plus 19.47, which is this value here. So x is minus 160.53. All of them are degrees. So these are my 4 solutions. And these are my 4 solutions. Then they say hence, using what we just learned, don't forget the hence means you should use this part of the question. Find the smallest positive solution of the equation. Now I have the same equation, but instead of x, I have 2 theta minus 30. So which means all these solutions are going to give me solutions to 2 theta minus 30. So 2 theta minus 30 is going to be 14.48, 165.52, minus 19.47, minus 160.53. And I will have a different interval. Remember, this interval will be modified multiplying theta by 2, or the angle by 2, and subtracting 30. So my interval is going to be actually larger. It's going to be, if you want to think about it, it will be between minus 390, so 2 theta minus 30 and 330, but I don't need to find more solutions than the ones that I have here, because they are asking me about the smallest positive. So it's going to be using this one or using this one, really. So if I use this one, and I have 2 theta minus 30 equals 14.48, it's going to be negative, right? So when no, it's not going to be negative, sorry. It's going to be greater than the other option that I have, that is the 2 theta minus 30 is minus 19.47. Yeah, so my solution is really going to be between this one and this one, but this one is going to be smaller than this because I have a negative thing here, and in this case theta is 5.26 or 27, depending if you use the value without rounding or rounding. Yeah, so both answers would be correct, but this is the smallest angle that gives me the correct answer, the smallest. Yeah, these others will give me larger answers, and that's it. That's part B, right? This bit there, and that's all with this exam question.